Welcome back. We are looking at graphing rational functions, and we've been talking about domain restrictions, specifically holes. And we said that holes are any domain restrictions that disappear through simplifying. If a domain restriction does not disappear, it's going to be a vertical asymptote, which we looked at in our last, in graphing reciprocal functions. So when we work through these problems, we are going to be looking for our domain restrictions, and we're going to do that by fully factoring. Once we've fully factored and found our domain restrictions, we're then going to simplify to decide if we've got holes or vertical asymptotes. So in this example, we're finding vertical asymptotes and holes. I've got three different problems. So my first one, y equals x squared minus 4x minus 5. Step one is to fully factor. This factors to be x minus 5 times x plus 1 over x plus 1. My domain restrictions at this point are x cannot be equal to negative 1. I'm now going to simplify, canceling out any like factors, and I see that my function simplifies down to x minus 5. So this does not appear to have any domain restrictions. Because the domain restriction of x equals negative 1 no longer appears here, we have a hole at x is equal to negative 1. To find the ordered pair coordinates of the hole, like in this example, we physically drew a hole at the point on our graph that's missing. We are going to plug this x value into our simplified form of the equation. So that's going to give me y is equal to negative 1 minus 5. So y is equal to negative 6. So there is a hole at the point negative 1, negative 6. So on my graph, I would physically draw a hole at the point negative 1, negative 6. So I would draw an open circle at that point. So this gets an open circle. Only that point doesn't exist on my graph. Okay, if I look at my next function, first step is I need to fully factor. So the numerator, x minus 1, is fully factored. My denominator, I'm going to need to factor this. This will factor into x minus 5 times x plus 2. So my domain restrictions here are x cannot be equal to 5 or negative 2, because those are the values that make my denominator equal to 0. Nothing cancels out. So because they still remain here, I am going to have vertical asymptotes at x is equal to 5 and x is equal to negative 2, and there are no holes. In this graph, in this example, there's no domain restrictions in my final simplified equation. So there are no vertical asymptotes here. In our next example, y equals 2x squared minus 7x minus 4 over x squared minus 16, we're going to start by factoring the numerator and factoring the denominator. Denominator is super easy, difference of squares, x plus 4 times x minus 4. And in my numerator, this will be 2x and x. I think this is 4 and 1, and this will be minus and plus. So my original domain restrictions are x cannot be equal to negative 4 or positive 4. That factor cancels out, so this simplifies down to be 2x plus 1 over x plus 4. This is my simplified. In this problem, the domain restriction of x minus 4 still appears, and the domain restriction of x equals 4 disappears. It cancels out. What that means, the domain restriction that cancels out is going to become a hole. So there's a hole at x equals 4, which means I am going to plug into my equation 4, into my simplified equation. So that's 8 plus 1 over 8, or 9 over 8. That means there is a hole at the point 4, 9 over 8. And the domain restriction that still appears is going to become my vertical asymptote. So this problem will have both a vertical asymptote and a hole. Problems can have vertical asymptotes and holes. They can have multiple holes. They can have multiple vertical asymptotes. Any combination of those can exist. We just need to check for domain restrictions and then see which ones cancel out and which ones stick around. In our next video, we'll be talking about horizontal and slant asymptotes.